Okay, we'll now get into the k-means clustering method.
We can minimize this.
So what happens in k-means clustering method is this. So first of all, there are so many objects in the space, and what it does is it will assign. Just suppose we are trying to make two segments here, so it will just assign two centroids here. So you'll put a centroid here and a centroid here arbitrarily without random. In the next process, what it will do is all the points that is closer to the centroid will become that one segment. And so for example, you had a centroid here which is black in color and a centroid here which is red in color. So everything, all the centroids that are closer to this will become black. Everything that is closer to this will become red. Okay. In the next process, all these will now look at and assess what is their centroid now. Okay. So this centroid which was here may change to here. So your centroid changes here. Okay. Similar that this centroid changes here. So basically, as the centroids keep changing and the iterations keep happening, and it keeps happening till the centroid cannot change anymore. So it can be 2 centroids, it can be 3 centroids, depending on how many clusters we have. And in k-means clustering, you need to provide an understanding of how many segments you need to have. The advantages of this is it is very prevalently used and simple. The disadvantage is you need to specify how many clusters you need, and there are statistical ways to arrive at what is the best optimum way. I know in SAS and in several softwares, there is a way to first find out what should be the k, what is your k to understand how many clusters you should have, because having too many clusters is not manageable, right? You may have 50 clusters and you cannot work against all different clusters. So 5, 6, 3 to 6 is usually the number of clusters companies or organizations tend to use. But yes.
K value, you get the best outcome.
Yes.
When number of clusters, the K value, you can do the number of clusters.
That is the highest number of value you can have. Yes. So what they do is there is the curve which traces a graph between error of k versus k, and it's a elbow kind of curve, and wherever the elbow actually flattens out is the value of k that you should take. So that is one way of it. There is a statistical measure of finding out what is the optimum number of clusters you should have. The next is hierarchical clustering. Hierarchical clustering is basically what we are doing is you are representing the segments through a cluster, and you are starting with, there are 2 different ways of doing it. One is, as you mentioned, one is a divisive, another is a agglomerative. Agglomerative is, so in divisive, you are starting with one cluster. Every item is a cluster. Then you are going to combine whichever items are closer to another, and you are going to combine clusters. So you are going to get those trees, and you are going to end up with one cluster at the end. In the other process, you start with one cluster and you determine the fragmentation, and you go further. And this is one way to look at it. Hierarchical clustering is very difficult when your number of cases is very difficult, because you have to start with all the clusters, all the records, and it's very time consuming, very expensive, very sometimes very difficult to do as well. So as I mentioned, you merge the nodes that have the least similarity and start with point in cluster and merge clusters based on some criteria. I will quickly go through the collaborative filtering. As I mentioned, this is primarily used in Netflix recommendations. So you are basically given a database of user preferences. So I have preferred movies A, B, C, D, F, whatever. And so I want to predict preference of a new user. So new user could be very similar to mine, for example. And the good advantage of great advantage of collaborative filtering, it can be run live. It is purely based on data. It can be personalized to you. So what it does is it creates a matrix, and it recommends you based on if your profile is very similar to another profile in terms of the ratings. For example, if Kumar had a similar rating for a movie and as mine, and there is another movie which is very similar, and Kumar has liked. It may not be similar. It's Kumar has liked, then I'm likely to like the movie. So the assumption is similar items will have similar ratings. The other thing is similar people will like similar products. So that is the assumption behind it. So what it can do is you can recommend items, and it's based on user based as well as item based, right? So user based means we look at the kind of the similar users and recommend what we all like. So Kumar and me like XYZ. So if he has not seen this and he has rated this, if I've seen this and rated this, he's likely to like it. Content based is recommended based on item features. So for example, a item has a X as a director, and Kumar has liked it, and I'm similar to Kumar, then I'm likely to like that. So it can be based on item features as well. It could be based on user features. So me and another person have the similar kind of demographic characteristics, and recommendation can be made based on our recommendation characteristics. The basic steps are there. So you identify the set of ratings in the for the target user. You identify the set of users who are similar, and you make the recommendations. So you can recommend based on your past preferences as well as your preference for new base. The disadvantage with that is that if you are a new user and you have no record of anything, it's very difficult to predict, obviously, right? And the other thing is, if I have interest outside what I have already established, then also it is not going to track it. So whatever information you have fed is the information it is going to get back to you. But the bigger advantage of collaborative filtering is it can cater to your unique tastes. So if your taste is specific, it can cater to you, and it is customized and it is easy to explain. Association rules are something that are used. It's also called market basket. Pardon? Oh, confusion metrics will not apply here because this is not a prediction, right? So, not that I know of, because that is purely comparing different models based on, because you know the outcome of interest you are able to generate. But this will depend on, for example, Netflix, when it had this Kaggle competition, it offered $1 million. It said you have to improve our model by 10%. So their model was, and you have to, it's a measure of its own performance. So yes, correct. Yes.
Sometimes in these unsupervised, you need sampling theory. So you create your own samples just to test them. If you need more, one of the top models, they use Monte Carlo. That's depends totally on sampling theory. You don't have any sampling, and you want to protect something. Like you have a new item in the market, nobody sells it. How you can, how much I can sell, where. You created a sample. Some of these we use like just you do samples and you know those samples is right. So I will, yeah, then you test your model and see if you can detect something.
Okay, assertion rules are primary example is in market basket analysis. So basically, it is a retrospective approach in the sense it has already happened. Unlike your collaborative filtering, which can be live, this is a purely a retrospective approach. So you are saying the goal is to find who makes the purchases and what do customers buy. This is primarily used in marketing, I know, but it can be used anywhere else. So this is one example where you buy milk with cereal, you bought tea and milk, you bought tea, rice and bread, and you brought cereal, and you have a whole list of combinations. So what you do is you have a database of all kind of transactions, and you find, okay, how many people bought this and this. So if I give a promotion on this, then I'm going to generate your upsell of another item, right? So if people are buying milk and bread, and I give a promotion on milk, I'm going to increase the sales of bread as well. I may increase the price of bread in the same. So it will increase my profitability. So there are a few things. One thing is to look at extract the rules. The rules are people buy this, this, and this, or this and that are the most frequently bought items. So one rule is 80% of customers purchase X, Y, and Z together, for example. There are association rules. So for example, 60% of customers who purchase X and Y also buy Z, right? And there are sequential patterns. For example, people who bought X after 10 weeks are buying Y. So there are different ways of looking at it. So based on understanding these patterns, you can actually orient your marketing activity to actually, so where are the applications? So for example, it can be used, how can if you want to boost the sale of a particular product item, you can do it. That is one, how do I boost the sale of potato sales, for example, chip sales? And what products would be affected if I discontinue this product is one application that I can use. And also, which product should be sold with bagels to promote the sale of potato chips, okay? Okay, and also, how do I manage the self, right? So what kind of self-management will I have so that people will buy this and the other? Outlier detection is nothing but you are trying to find out points, records which are out of the normal. So something that is out of the ordinary. For example, fraud detection is one area. I won't go into details on this because of time issues, but fraud analysis is one area where outlier detection is very common. You need to find out those outliers. In all the data mining techniques that we use, we actually remove outliers so that we can do a model properly, because outliers can mess your model. But in fraud techniques, you actually do the reverse. You are trying to find out, you are trying to ascertain which are those outliers so that you can understand what happens. And the outliers could be disease, outliers could be fraud, outliers could be churn, outliers could be anything. But your disadvantage is you need a lot of cases to understand it, because outliers are very rare by its very nature. Model comparison criteria, there are different. You have to compare model based on accuracy, speed, robustness, means impact of the noisy data, whether they're able to give correct predictions, and also, of course, scalability. If you add more cases, are they able to perform properly? And first, most importantly, it should be interpretable. Anything that you do needs to be explained and why it is happening, what is the logic, and without just a statistical model, it is not going to give a buy-in with your management or marketers who are going to implement your model. Just a statement I found somewhere on the internet as to what models are the first choice and what algorithms are the first choice for different kind of techniques. So the green is the first choice, the orange is the second choice for different kind of algorithms. So you have algorithms on the top, and you have the different techniques, data mining techniques on the column. Issues and challenges, as I mentioned, this is my last part. First of all, data complexity, as I mentioned in the last last meeting. Data is extremely complex, and cleaning it takes most of your time. It is going to take most chunk of your time. It's going to be a big challenge as even your database is huge, and you have to deal with missing data, noisy data, sometimes incorrect records, incorrect punching, incorrect entries, and there are different ways to get around those issues. And right now we have different kind of data types. We have web data, we have streaming data, we have text data to analyze, we have legacy data which is lying in different kind of platforms, and you may need to integrate all those information. Data transformation is you cannot use the data as is for any kind of modeling. You may have to do a factor analysis or a cluster analysis to actually combine variables, to take away variables, to make what makes sense. So your model may not work without a data transformation. You need domain knowledge. Without the statistician cannot really give you a model without understanding what is. So, for example, somebody who is in healthcare and has this knowledge will be able to better, because, as I mentioned, interpretability of the model is also very important. He might need to explain so that there is proper time. And if it is happening real time, for example, there are models that are implemented real time versus something that is high performance. So there is a difference. We have to look at those issues as well. There are different models that can underfit or overfit. You have to be very careful with that. So it will take time to use as many as techniques as possible, as many algorithms as possible within the time frame as possible. And the most important thing, your time of analysis and time of, you need to properly budget your time for data cleaning, data transformation, data analysis, and modeling. And usually that is where people go wrong, and it can be a huge exercise. Everything can fall apart. And the pattern evaluation, the interestingness. If you do not find anything interesting, it will not have any buy-in. The entire process goes waste. So you have to find something interesting, something that will say, some ahas, that will really help, something that people did not know before, and something that can help your business. And you should look at whether it's a one-time exercise or the recurring exercise. For example, segmentation. For example, you do a segmentation. Now, we did a segmentation for a bank, and every year there are churn and there are new people coming in. What happens to those new people if you have not, and what happens to people who have churned, right? So if it's a recurring process, the segmentation needs to take care of it. So it has to be an ongoing exercise. And of course, you should have the resources, the technical expertise. Privacy and security issues. As we are trying to find out different ways of matching the data, we might have demographic profile data. Now we are trying to find out other ways of matching those people with people going to Facebook and find out what they like. And there are companies who are doing it. They're infringing into privacy and security issues. So, and of course, how do you interpret and visualize? How do you demonstrate your results in terms of what your model is going to provide? And finally, popular data mining tools, slightly older data, but yeah, we will just showing you how all these databases are is very popular, and SAS, which is expensive, which is not an open source, is actually 11% market share. This is North American data, and of course, this has all the uses and advantages of all these different. These are the top data mining tools only. I'm not talking about. There are so many data mining tools around in the market today, and but these are the ones that you need to be aware of. These are among the top few that are in demand. So, and there are advantages and use cases that may be of interest. H2O, Spark, NIME, Orange, Python are very popular. If you need to specialize on any of these, you can. This is a good way to look at it. And I think that's it. Thank you. Thank you.
We'll take a 10-minute break. So that was a very good session, Krish.
Thank you.
I hope you'll have some stomach for